All right. So are there any questions about anything? All right. So we're going to start looking at Flex today, and there will be an in-class activity, and then we should, before the end of class, should have well in hand what we need to know in order to do assignment 3. Which is due at the end of day on the 3rd. Which will be end of day Sunday. And the assignment's actually pretty straightforward, so I believe by the end of class you'll have it well in hand. I typed this in before, the original, I'll type them in again. So there are two parts that we're looking at here at the compiling process. The first part is the lexer. That's what we'll be concentrating on today and with this first assignment. The second is the parser. So again, the lexer, the scanner, its purpose is to turn the input into a set of tokens. So for instance, after lexer might have something like there might be 3 of these. Let me actually put in parentheses after each of these. There's something called the lexeme, which is the value associated. So these are, I'd call these tokens, and there are values associated with some of them. For instance, this one would be, that would be the value associated with that one. This one would have IOStream associated with it. This one is using, that actually go 3 ways. So
the semicolon.
Yeah, so I'm missing that. Where does that need to be? Right here. Oops, yep. All right. So this is what the parser gets. And you all know by now that C and C++ are very flexible languages with regards to spacing, that in fact that'll compile just as well, right? The new lines, the spaces, the indenting, that's all just for our ease of interpretation as humans. As far as the compiler is concerned, it wants to boil all that down to a set of tokens, which it does here. Those tokens are then passed to the compiler, which will then, one, make sure that they're semantically appropriate. For instance, this will go through Alexa just fine. It'd be something like t int type, t variable name, something like that. That'll go through just fine as well, right? T int type, t variable name. So as far as the Lexer is concerned, it can put that into tokens just fine. It's the parser's job to figure out whether semantically that's correct or not. Okay, so that's where the division of work is. So what we want to concentrate on today is just this first part of turning it into tokens. Now what we'll be doing is the assignment will have us actually printing these tokens out to the screen. Once we get down and are marrying together the Lexer and the parser, then these will actually be values that are passed to the parser. Right? They aren't printed to the screen just for the parser to have to parse them all over again. We just want, this is number 43 and this is number 48, and then there's some text included with it. This is number 64, and this is, right, you get the idea. They're just constants that are returned, and so the parser then takes action on all those. Now we don't have to deal with those numbers. On the parser side, we refer to these words just like this. But think of them more as constants or variable names or something like that, as opposed to what we're doing at this stage, which is we'll just simply print this to the screen, since we don't have a parser to deal with yet. All right. So I'll leave that there. Being able to being able to scan that and turn them into tokens, we need to know about regular expressions. Now I think there's a class, how many people have had some sort of regular expression coverage? What was that in, like discrete structures or something like that? Oh yeah, you get it a little bit in shell, I guess, that's true. You get into it very deeply? Huh?
315.
What's 315?
Programming languages.
Okay. So we're going to use them in practice now. Let me jump to right here, the Flex and Bison resources link. I got several of them here. The C graphical representation is pretty cool. We'll look at that in a little bit. What's immediately useful is this testing regular expressions. So you can go ahead and there's a cheat sheet here. So when you're figuring things out, you'll want to look at the cheat sheet or get on the web and do some searches. But to test them out and see how they work, this is a great site for that. One thing you want to do right away is come over to this flags drop down, and for every case in this course, we need to be dealing with multiple lines. So click on multi-line. If it'll let you, for some reason it's not letting me. Oh, yeah, it is. All right, I'm just not seeing it. The slashes that you see here, note it's giving me a little tooltip here saying open indicates the start, this is indicating the end, and then there's some flags here. The M, it means multi-line, the G means do it globally on a line. Normally a regular expression, if I want to look for, let me get rid of all this stuff. If I want to look for the letter A, it will normally, a regular expression will normally only match the first A on each line, meaning this first one here that you see highlighted. The G means look globally on the line, so in this case it's finding all letter A's on the line. Right? and then it repeats the process for each line. So we don't have to deal with these slashes or these flags for what we're doing, but that's why they're there. You have to do them in some cases. Sed, which stands for Stream Editor. Let me come here to my which sed. So sitting in the same place that ls is sitting. This is a stream editor that streams as in a stream of text coming at you. This is a fantastic tool for editing streams. You do end up using those slashes, kind of like that. But with Flex, we don't need to worry about the slashes or these flags that come after it. We're just concerned with the juicy pieces right in the middle, the expression itself. In this case, the letter A. All right. So the purpose of the regular expression is it's kind of a language for you to be able to do matching. They're literal matching. For instance, well, you saw A or and. That'll find everywhere there's an and. The. You can find either word. If I want to find a, let's see, do I have any numbers in here? One of the things you can do is add text in here. So obviously if I put a 9, it's going to find both of those 9s. But note that these are separate matches. It matched to this 9 and it matched to this 9. If I wanted to match 99, I, of course, would have that. So that's a different thing that's being matched. There's one match here. There's 2 matches with just a single 9. What if you want to find any digit? Not necessarily 99. Let me throw some other numbers in here. 782. So you can specify a range with square braces, or not a range, I don't want to say a range. You can specify multiple characters in the square braces. So let me do something we've already looked at and see how this is different. If I put the inside of the square braces, that is saying match any letter T or any letter H or any letter E. And if you, let me see if I can zoom in on this without it killing me too bad. If you look carefully, I don't know if you can see it on the screen, it's actually, you see a little bit of white space between each of these showing that these are considered separate matches. It's not matching the word the, it's got 3 separate matches. That's what this expression is matching, each of these individual characters. You can do a range. So, what if I want to find any digit? What my digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Note now that's matching each of my digits individually. It doesn't have to be in that order. I could say 8, 6, 4, 2, 1, 3, 5, 7, 9, 0, right? So the order doesn't matter. You're literally just throwing a bucket full of characters in there, and if it finds a character that matches, then life is good. But it is very common to do ranges, so that works. You can find all uppercase letters. Note that, let me go back to this. That's finding any digit 3 and any digit 4. They're just crammed together, right? Why do I not have a space there? What if I put a space there? That means then look for any digit 3, any space, or any digit 4. So don't think about putting spaces in there for readability. You're actually changing what is being matched if you do that. So what if I want to find all uppercase letters and all digits? Yeah. And no spaces, you just put them in there. So this matches, these are all single character matches. I can modify let me take that away. That matches any single letter N. What if I wanted to match one or more letter N's? Then I'd put a plus in front of it. That means one or more of the previous character. So note, again, I don't know if you can see it on my screen, but watch this. Let me actually see if it's going to let me zoom in there. All right, these two letter N's right here, I can't put them any higher, sorry. Oh, I bet I can do this though. There we go. Now watch when I remove the plus. Okay, you see how it's now showing these are discrete matches? So this is two separate matches there on the word Skinner. Let me go back to where I can read this. That's one match on the word Skinner. Okay. So you can do that with like a range of numbers. So this is where it starts to become useful. If you need to match all numbers, this isn't useful to us because I need to match not 782, not a 7, an 8, and a 2. So I put the plus in front of it. Now it matches 782. What about this? This is part of a number. What if I put a negative in front of it? How am I going to match that? I can put a negative sign here. Now it does it, right? So this expression that goes from this forward slash, knock that off. Stop that. This expression that matches this character followed by one or more digits. However, not all numbers have a negative sign. For instance, this 99 doesn't, and note that I'm no longer matching the 99. I want to match both negative and positive numbers. So I need a way of saying 0 or one of them. This will give me 0 or more. So the asterisk means 0 or more of the previous character, and the plus means 1 or more of the previous character. And now I've got a, let's see, the question mark I believe is 0 or 1 of the previous one, and that's what we actually want in this case. We don't want an asterisk because that would also match negative, negative, 782, and I only want that one that's closest to the 782, so I go ahead and put a question mark there, and it won't grab that one prior there. So we have the asterisk, the plus, the question mark, those are modifiers. We know that we can use the pipe to separate. Let me go a little bit smaller. And I want the plus. So the pipe's going to give me, ORing those two together, it'll find all numbers and the word and. What other things come to mind real quick? One thing that you should not confuse these wildcards with is when you're working on the shell. So you might say G++ asterisk dot CPP. So it's definitely a wildcard, but it is not a regular expression. The asterisk in this context is a wildcard as interpreted by the shell, and what you have to do is you have to research like do a man look at a man page on Bash and find out about wildcards, and they've got a totally different, and I don't even know how they're doing it, globbing. Pattern matching. Pattern matching. So note that matches any string including the null string. That's different from saying 0 or more of the previous expression. So this stuff shares characters and similarities, but it is not regular expressions if you're just typing at the shell prompt. Okay, they are different. Also, this matches any single character. That's different from 0 or 1 of the previous thing, which, by the way, can be useful. For instance, if you want to do so I've got these CPP files here that I'm interested in manipulating somehow, but I'm not interested in manipulating this one here. I guess there are a number of ways of doing it, but one is that you could do that. All right, so that's how that wildcard works at the shell. Anyway, I'm getting off track. If I want to remove them, same thing. So what I want, let's take a look here, see what this assignment is. I want you to do something in class. Another very popular character to use with the stuff in the square braces here is if the very first character immediately after the open square brace is this caret, that means it's negating what you have inside the square braces. So that's saying match anything that is not a digit 0 through 9. And you can see that that's exactly what it's done. The 782 and the 99 are not selected. So oftentimes it's far easier just to negate a few characters rather than trying to match every character except 3 or 4 odd ones. And I think that's enough. I think what I want to do is I want you, so this is not to turn in, I just want you to take a few minutes, get together, use this as your starting point, and get together with someone next to you and see if you can bust out the answers to all of these here, and then we'll talk about them in a little bit. So why don't you go ahead and do that. So let's go ahead and talk about some of these. Apple. I assume everyone spelled apple correctly. I like apples and bananas. Apple or banana. Apple or banana. Any integer? We looked at that one already. What did we say? We said 0 or 1 negative signs and 1 or more digits. Also, what if you want both not only, let me see, what did I say? So I didn't include it there on number 3. That's going to match 99. That's going to match negative 99. What about positive 99? What about the plus? How can I get that plus in there as well? So you can use parentheses for grouping. So I could say plus or minus 0 or 1 of those. Whoops, except I need that because plus means 1 or more characters. Yeah.
You also put brackets?
You could also use brackets, so absolutely, and that's actually the way I probably would have done it. I probably would have just said uh, 0 or 1 plus or minus characters followed by 1 or more digits. Any double? Let's go to that. Let's leave that for last. That one's a hard one. Anything that is not the digit 3, the letter X, or the letters J through P. What do you got for me? It is not digit 3. A 3, an X, J through P. That will match everything that is a 3 and X. Let me throw in a 3. Let me throw in an X. We got the J through P in there. How do I negate it? Put the caret. Now it's everything but those. The word the appearing at the end of the line. I'll give you part of it. $, yeah. That should only hit that the right there. At the beginning of a line, I need what about this one? How about if I can handle both an uppercase T and a lowercase t? Oops. So the caret outside of the square braces is referring to the beginning of the line. How about the word the being the only thing on the line? So it should not match the first and third one, but it should match the second one. Put a $sign after these. Yeah, that's it. I forgot I had the caret there. So the beginning of the line, THE, end of the line. That ensures that that's the only thing on the line. That's everything except doubles. All right. Did anyone do it without Googling it? Tell me what to type.
So minus question mark backslash plus question mark backslash period question mark.
It's going to accept
Oh, no.
minus plus. That's it.
So that's fine. We can take this. This is we kind of talked about this already, though, right? We can go minus plus 0 or 1 of those. All right.
And then brackets 0 to 9. Plus. And then we didn't have the plus, but and then backslash period question mark bracket 0 to 9.
Is that it?
We have a star backslash period star.
Like that?
Yeah.
All right. 99.99.99. Well, that did that as three separate numbers. Negative 0.05, negative 5 point. Let's see, are there any other combinations I'm not thinking of?
Also the negative, plus and minus.
Plus negative 32.32. All right, so I've got that. Well, wait a minute. Nope. Whoop. What's this? That one. This one it didn't do right because you have a. This is separate matches. It's negative 32 point and 99 by itself.
I think the top one also, if you get rid of one of the nines.
Do we have the same thing? Yeah. All right. So close, but no cigar. Give me another one.
Okay. I have plus minus in brackets, question mark.
All right.
Okay, backslash D plus backslash period backslash D star or plus minus question mark in brackets. Backslash D star backslash period backslash D plus.
That looks pretty good. Yeah. All right. So the D is short for digit. That's just basically the 0 through 9 in the square braces. It depends on the flavor of the regular expression engine, whether or not it will accept something like that. So you just have to, when you start playing with different tools, you find there are little quirks and differences between them. So keep in mind if the backslash D doesn't work, just put the 0 through 9 in square braces, which will be pretty much guaranteed to work on any regular expression engine. I can show you what I came up with. Let me see. Let me put that. You want me to put that in the notes? Oops, I didn't want that. Stop it. The one I had done. Now I'm a little bit nervous. I'm wondering if mine will match all these. All right. So I did it the old school way. None of your highfalutin backslash D's for me. Ooh, look, I didn't get. Yeah, I don't have the plus or minus stuff in there. No, I didn't get it here. So I have to actually propagate that to. So all this is doing is it's finding the plus or the minus optionally, and then 0 or more digits followed by a period followed by 1 or more digits. So that would get point and a number, and optionally with something in front of it. And then this bit here is going to get optionally point and a number, but you're guaranteed the number in the beginning with the point. So the 32 dot. That's what that one's catching on the second end. So a number of ways of doing it. It's a well-exercised regular expression that you need to do, so you could Google it as well, and you should come up with many variants. I'll copy. I'm not sure I'm proud of mine, but I'll put it in the notes anyway. All right, so let's talk a little bit in the last 15 minutes about flex. I'm going to put curly braces here. The curly braces are optional if there's only a single action. But if you have multiple actions, you do need the curly braces. What are the actions? Code. So in essence, action, map it to statement. If you only have a single statement, C++ statement, then you don't need the curly braces. But if you had several, just like if you have several statements under an if or under a loop, then you need to put it in curly braces. Same idea. And I'm going to pull, I'm not sure it's going to be, there we go. All right. So right now, and then what I have here are double percents separating these three sections. This one, you would have definitions both in the traditional coding sense. For instance, you have to define a structure that you're going to use, or a class declaration, something like that would go up here. Pound include statements, right? Things that you'd put at the top of your code file normally. These are the rules, which I'll look at in detail in a moment. These patterns are the regular expression patterns that we've been talking about and the action that you take as a result. User code is dutifully copied by Flex and is not examined at all. In other words, what Flex does is Flex generates a code. It generates a lot of code, C code. And this portion down here, it just blindly vomits out at the end of the stuff it's generating. So any functions you want to define, things like that would come here. You say flex first.l. By running flex first.l, it creates this. So note that it ends in a .c. Throws a .yy in there. One thing that you get trained on, particularly in the Windows world, is that you can only really have one dot there. Maybe it isn't that way anymore. It used to once upon a time. Sometimes this throws people. The dot actually has no significance in the Linux operating system. A file is a file. So the only thing where dots have meaning are at a higher level of abstraction. For instance, a web browser. If you browse a file that ends in a .html versus a txt, the web browser is doing the interpretation of that, right? The operating system, the Linux operating system, could care less about extensions. So the multiple dots here don't freak anything out. Let's look at this code. So for an empty Flex file that does nothing, generates about 1,500 lines of code. A lot of stuff here. Look, note that everything that you see in here, why, you ask? To answer that question, you answer the question, why are there namespaces in C++? What is the classic major use case for having a namespace in C++? Why does that exist in the language? What benefit is it giving us other than forcing 111 students to type using namespace standard at the top of every file?
Name conflicts.
Name conflicts, exactly. So back in the day, this is C code that's been well formed so that it'll compile with the C++ compiler. There weren't namespaces, and so they had to be sure if they used names for their variables and their functions like parse and scan and stuff like this, common names, then it was likely going to collide with your own code that you've written. And so their best effort to make sure their stuff doesn't collide with any of your stuff is to put YY everywhere. So as long as your code doesn't have YY, then you're probably not going to collide with this stuff. So that's the reason for it. It's a historical reason. Let me try compiling it. No, hang on. I'm on my Mac. I don't want you working on your Mac. You need to be in Linux. So let me come over to my Linux box here. It's freaking out. Let me fix my Lexer up here. I don't think it. Let me actually just get rid of everything. All right. There are a couple things. One is not quite getting what I want, so let me add a little bit of code. One thing this is going to complain about is it doesn't generate a main function for you, so you have to create your own main function. And I'll correct that spelling momentarily. I'll probably still get I don't have enough code here, so it's just complaining. It doesn't want it to be empty. Oh, I know what the problem is. So what can I do in a no return statement? Huh? Why is it doing it to... Oh, I'm flexing. There we go. I'd run flex on my Mac, so those differences were causing it to screw up. All right. Now let me go back to where I was. Run flex. That generates this file. Regenerates it in this case. Try compiling it. It actually compiled just fine based on our conversation yesterday. What kind of error is this? Or not yesterday, Tuesday? Who's complaining? The linker. It compiled just fine. There's nothing wrong with that code. It isn't linking. Why is it not linking? I already gave away the answer to some of it. One is you have to provide a main function. So let me do that. Whoops. Why is it still complaining about main? I put a main function in there. Huh? No, I got all that. It compiled fine. It compiled fine again. I made an error in workflow. What is my workflow? Got to run it through Flex, right? I made edits to the Flex file, but I never ran it through Flex again. So don't make the rookie error I just made. Run Flex again. Now compile it. Okay, now I no longer have the undefined reference to main, but I have this YY wrap error. There are a couple ways of resolving it. The easiest way to resolve it is up here where you're providing definitions. In addition to your definitions, code-wise, there are several definitions that Flex understands. And I am interested in that. It's complaining about no YY wrap. It's we don't need no YY wrap, so we just tell that option. Excuse me. Yeah, I think that's right. Let's try it. Flex, compile, voila, and it does nothing. All right, let's have it do something. We can. Yeah, let me go with that. What is that? So my regular expression comes first. Again, these were in the pattern action. Again, I don't need these curly braces, but it's a nice habit to get into regardless. So if I find what, I'm going to print found one. Any character. Let's try it. Flex, compile, whoops, what did it see now? So now we got this stuff, right? So we have to say pound include iostream using standard cout. So that's all of my definition stuff up here. Flex. No. You have to do one of two things with your code. You either have to indent your code up here, or what I think I prefer, you could do it either way, but what I prefer is they have the special note that percent seems to be the thing that causes Flex to do magical things. And so like percent option, a percent open and a percent close will bracket your code. The reason I like this better is I'm getting syntax highlighting in my editor. Whereas if I just do that, I'm not. So that's more pleasing to the eye, so I prefer that method of doing it. Flex, compile, okay. This actually is still not going to do anything. Why is it not going to do anything? What does my main function do? Return 0, right? So all of the code that is being generated here comes down to creating a function that we can run. Note, here's the code that it pasted at the bottom. Note it is at the very bottom of the file. The function is yylex. That's the function that Flex generates. It generates a bunch of functions, but that's the one that we call to do all the heavy lifting. Run it through Flex, compile it, run it.
You just ran it through Flex after editing the output file from Flex, right?
Say that again. Oh, yeah, that's what I did. All right, got it. Thank you. Let me try again. yylex. Now, run it through Flex, compile it. Reads from standard in, writes to standard out. That function does. Hi there, or hi 3. Let me do ABC. Let's make copy and paste here. If I find any character, print found one. If I find a new line, print print the word new line. If I have a 2-3, print 2-3. But we should see something interesting. Let me create some file, some input.txt. So I have a 2, 3 in here. I have a new line at the end of this. There's actually a new line at the end here, and the rest are just characters. But if I run it, it actually gave me what I wanted. So let's look at what the assignment asks you to do in the final 2 minutes here. You're given this input file, which is just a couple sentences. And what you have to do is write a flex scanner that prints out parts of speech. So when I say prints out parts of speech, like this word quick, prints out T adjective, it would look like this would be quick. Just like that. No spaces or new lines, just the word. Right? Starts with the letter T, ends with the letter E. Nothing else. No end line, nothing. So that's what you have to do with all these. One rule for each part of speech. So it says one rule for each part of speech. What does that mean? I've got of, on for prepositions. I've got over for prepositions. One rule, not 3 rules. This makes sense? Okay. So that's the only trickiness. And after everything you've done now, I don't believe it's that tricky. Here's a shortcut, a little tip. So this is what this is saying is this is shell logic. Do this command and do this command. Shell logic is the same as C++ relational logic. So we're familiar with short circuit logic in C++. If I do this, if some func and another func. If some func returns false, what is the likelihood of this if statement being true? 0, right? Short circuit logic is saying if this first one is false, there's no need to even evaluate this. So another func never gets called if some func is false. So looking at the shell here, this, if you combine this, rather than me doing it as 2 separate commands as I've been doing up till now, you run flex. Running this command, flex actually returns a success code. You can see that with any Linux command. If I say ls and then I say echo $? That's 0. But if I say ls, a file that doesn't exist, and then I do $? I get a non-zero code. So when I'm doing this, if the flex command is successful, then it'll go ahead and compile. But if the flex command has a problem, then it won't compile. Right? So that's kind of a nice way to save you time and make sure you always remember to do flex before compiling. All right? Okay, so that's it. Go ahead and do that. Any questions, go to Piazza, and we'll see you on Tuesday and keep plowing forward into the parser.